Insect juice is keeping the examination world in tension after the red supergiant stood out in recent years with extreme changes in brightness. Some experts believe that the explosive death of the celestial giant is imminent. However, the right shoulder of Orion is creating a ruckus once again. On one hand, there is the theory that Betelgeuse is rotating much faster than it should because it once devoured another star. On the other hand, there is the assumption that the celestial giant is not alone and may even be a binary star. This raises questions. Why hasn't the companion star been found, and how would its presence contribute to the formation of a central mystery in our understanding of the universe? The Sun often represents the extreme in the universe, no wonder, since in theory, Earth could fit into our mighty mother star around 1.3 million times. Although the Sun, with a diameter of nearly 1.4 million kilometers, can confidently be described as impressive, we shouldn't forget that there are far larger celestial bodies out there that would make our central star look like a tiny speck of dust. So, a quick reality check brings us back to the galactic facts, and we realize that Betelgeuse surpasses the Sun in every possible way. Located around 650 light-years from us in the Orion constellation, this red supergiant's diameter is more than 1,000 times larger than that of the Sun. This massive difference in size is also reflected in terms of luminosity. In fact, Betelgeuse shines a whopping 100,000 times brighter in visible light than our source of heat and life. In space research, the principle that exceptions confirm the rule clearly applies. A few years ago, Betelgeuse presented scientists with a huge mystery when it dramatically lost brightness within a few weeks. The stellar dimming was so pronounced that it could even be seen with the naked eye in the night sky. In principle, periodic brightness fluctuations are normal for Betelgeuse, but in this case, it dimmed much faster and more intensely than usual. A brief aside, the astronomical unit of magnitude indicates the apparent brightness of a celestial body, and the smaller the magnitude value, the brighter the object appears to us. With an average luminosity of 0.3 to 0.4 magnitudes, Betelgeuse is one of the 6th to 7th brightest stars in the entire sky. However, in December 2019, it dimmed to 1.1289 magnitudes, dropping to the 21st spot in brightness. Is Betelgeuse about to become a supernova? This question led scientists to search for explanations for this unexpected development. Since Betelgeuse, as a red supergiant, is nearing the end of its stellar life, the suspicion was briefly raised that its brightness drop was linked to an impending supernova. We remember that, when not experiencing a mysterious dimming, Betelgeuse shines 100,000 times brighter than the Sun. When it eventually leaves the cosmic stage in a violent explosion, experts expect it to experience a 16,000-fold increase in its current brightness. Betelgeuse would then reach an apparent magnitude of -9.5 to -1.5. Some scientists believe that the star will appear as bright as the full moon and should even be easily visible during the day. When exactly we can expect this dazzling spectacle is another question entirely. Most scientists have now abandoned the assumption that a supernova will happen in the foreseeable future. What was once interpreted as a harbinger of a cataclysm turned out to be a massive plasma eruption, which created a no less massive dust cloud that obscured the star by about 2/3 for our natural eye. As mentioned before, Betelgeuse has reached the final stages of its life cycle and regularly loses large amounts of stellar material. This material is transported to the surface by convection currents from the interior and ejected. But Betelgeuse also experiences multi-day cycles of expansion and contraction, and scientists estimate that the combination of strong contraction and expansion caused the plasma ejection to be much more intense than usual. If we compare it to the Sun, we see that Betelgeuse once again surpasses it. The rate of mass loss during this event was about 30 times higher than for our Sun. Essentially, the ejected plasma likely cooled in space and eventually condensed into a huge dust cloud. Since this cloud moved between Earth and the red supergiant, it appeared to us as a large shroud that dimmed the star. The rotation mystery: has Betelgeuse devoured another star? Betelgeuse wouldn't be Betelgeuse if it didn't hold a few more puzzles for astronomers. For example, Images taken by the ALMA Observatory's coupled radio telescopes a few months ago suggested that Betelgeuse is rotating at an unusually high speed for a red supergiant. The rotational speed is over 5 kilometers per second, which is more than 100 times faster than expected for a star of this spectral class. Jing Ma from the Max Planck Institute for Astronomy in Garching, Bavaria, points out that Betelgeuse is, in fact, the only known red supergiant thought to rotate so quickly. This rotational speed is attributed to the bipolar structure of the surface, where one half shows a blue shift, and the other half shows a red shift of several km/s. But what explanations do astronomers have for this surprising rotational behavior? The first theory is based on the assumption that Betelgeuse is a cosmic cannibal. In other words, when it expanded into a supergiant about 1 million years ago, it may have swallowed a companion star similar to the Sun. In this scenario, the absorbed star transferred the angular momentum of its orbit to Betelgeuse's outer shell, thereby accelerating its rotation. This theory was tested in a computer model, and substantial evidence for it has also been collected. Images taken by the Herschel Space Telescope several years ago showed 2 zones of ejected stellar material lying dormant on one side of the supergiant. These shell-shaped structures were interpreted as indicators of the coming supernova explosion. At the same time, they are found precisely at the distance at which they would be expected following a stellar cannibalism event. However, there are other possible explanations. Ma's research team points out that the surface of the star is decorated with large bubbles of rising and falling plasma that can cover a large portion of its visible outer shell. This is the critical point, as the rapid movement of these plasma bubbles can also generate the red and blue shift of the radio emission. In other words, it is possible that Betelgeuse is not rotating too fast but rather creating an optical illusion. If a very large convection bubble or a group of them is moving towards the observer while another is moving away, even a star that isn't rotating at all can appear to be spinning incredibly fast. A recent analysis of the ALMA data, combined with an astrophysical model, showed that this explanation is highly plausible. According to Ma, there is a 90% probability that the maps generated in the simulation would be misinterpreted as high rotation rates. This is mainly due to the low resolution of the ALMA images, which distorts the true characteristics of the movements on the stellar surface. So, at present, it's impossible to say with absolute certainty how fast Betelgeuse truly rotates or how likely the scenario of a swallowed star is. However, we can say that evidence is mounting that the red supergiant is not alone. Does Betelgeuse have a companion star? As referenced before, the brilliance and surface of Betelgeuse throb in a pattern of around 400 days. Well, as a matter of fact, the red supergiant has still not recovered from the enormous plasma ejection of 2019, and the reverberations of the ejection continue to create rapid motions in its interior, while the surface is still vibrating like an oversized jelly. According to astronomers, it will require quite some time before the star finds its way back to its usual rhythm. However, in addition to its 400-day throb, Betelgeuse also exhibits a secondary, longer brightness variation that occurs over a cycle of 2,170 days, or almost 6 years. But the reasons behind these long, periodic variations remained unclear for a long time. To finally change this, Jared Goldberg and his colleagues from the New York-based Flatiron Institute recently dedicated themselves to the task of re-evaluating all observational data on Betelgeuse. Indeed, the new analysis revealed a number of unexpected anomalies. These begin with the fact that the 6-year cycle in the star's light curve follows a rhythm distinct from the subtle 400-day throbs. In detail, the long periodic variations are shifted against the rhythmic throb. Beyond that, however, the researchers couldn't identify any accompanying phenomena that would be associated with causes like rotational sequences, magnetic field effects, or convection currents. Ultimately, the researchers concluded that there is only one possible explanation for the long-period oscillations that has no major flaws, namely, the presence of a smaller companion star. Otherwise, the unusual 6-year changes would thus reflect the orbits of this companion star. When the stellar companion is behind Betelgeuse, as seen from Earth, the secondary period is at its lowest brightness. However, when the companion is near Betelgeuse, the luminosities of the two celestial bodies combine, and the brightness reaches its peak. At the same time, the companion star could also act as a natural dust shifter, influencing the distribution of dust clouds and thereby playing an additional role in Betelgeuse's brightness fluctuations. So far, so plausible. But how is it that the companion star has not yet been detected? Well, the answer to this question likely lies in its low mass. According to the researchers' estimates, it weighs only around 1.7 solar masses. Betelgeuse, on the other hand, has nearly 20 solar masses. Additionally, the companion star is likely to orbit its much larger partner closely, at a distance of just 2.43 Betelgeuse radii, to be precise. In this configuration, the companion star is essentially overshadowed by its more imposing partner, and the brightness changes and throb of Betelgeuse further complicate the task of detecting the companion's traces in the light curve. And even though the chances of spotting the companion star with current telescopes are, to put it mildly, slim, the researchers now plan to apply for observation time at some of the large telescopes. In doing so, they hope to uncover additional evidence of the stellar companion's presence and perhaps even clarify what type of star it is. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.